Question 29 reads, Thomas is making a sign in the shape of a regular hexagon with 4-inch sides, which he will cut out from a rectangular sheet of metal, as shown in the figure above. What is the sum of the areas of the 4 triangles that will be removed from the rectangle? So the question is asking us, what is the area of this yellow region, right? All these yellow regions. And so we know that all of these sides are 4, 4, 4, 4, and 4. Okay, that's cool. But we also know that this is a regular hexagon. And so the way we solve this question is by a thing called the sum of interior angles of polygon. And I bet you usually learn about this in middle school or something. But what it says is that n minus 2, n being the number of sides in a polygon, into 180 gives us the sum of the interior angles of that polygon. Here, a hexagon, we should know, has 6 sides. And so 6 minus 2 into 180 equals 720. You can put that into calculator as well. It's going to be the sum of the interior angles of the hexagon are 720. And now, if I divide 720 divided by 6, because there are 6 angles, that means that each angle is 120 degrees. Each of these are 120, and it makes sense. And you may be asking why this is relevant. Because actually we're going to use this information to find the angles of these triangles, right? These triangles, and from the angle we can find the side lengths, and with the side lengths we can find the area of each triangle, because with the formula half into base into height. Okay, and so if this is 120 right here, this angle is going to be in this triangle's angle right here is going to be 60. Okay, because they are supplementary angles, they add up to 180, right? And so this one's going to be, if this is 60, this must mean that this is 30 degrees, and this is going to be a right angle, right? Because it is a rectangle. The shape is a rectangle. 60, 30 plus 90 equals 180. And we know that the sum of interior angles of a triangle is 180 degrees. And so that works out. And if you notice, this should ring bells in your mind. The 60, 30, and 90 combination, you should think about this triangle right here. Special right triangles, this 30, 60 triangle, okay? Because if you know this idea right here, we know the sides of this triangle. Well, here, we know that each of these hexagons have a side length of 4 inches, right? And so that means our hypotenuse, right here, our hypotenuse is 4. And in this example that the College Board gives us, it's 2x. So if I equate 4 to 2x, then x equals 2, right? The x right here is 2. And we know that x belongs to the shortest side. And so this side is going to be 2. And this side right here is going to be, in this triangle, they give it as x root 3. And so if our x is 2, that must mean this side is 2 root 3. I hope this makes sense. I'm just applying the knowledge of our triangle to this, right? Because R4, we have 4 as the hypotenuse. Here, the hypotenuse is 2x. And if I solve for x, that's going to be 2. And then I know x is the shortest side length, and the adjacent side is x root 3. And we know our x is 2, so it must be, this short side must be 2. And this adjacent side should be 2 root 3. Okay? So now I have the dimensions of one triangle. Okay? And so I can calculate the area of one triangle, right? And that's going to be half right here. Half into base, our base is 2, into height, our height is 2 root 3. And that's going to be it. So half into 2 into 2 root 3. That's going to be, half into 2 is just 1. So 1 into 2 root 3. And that's just going to be 2 root 3. So the area of one triangle is 2 root 3. But the question asking us for what is the sum of the areas of the 4 triangles, right? And so what we have to do is 2 root 3 into 4. These triangles are all going to be the same dimensions and area, because again, this is a regular hexagon, right? With the same side lengths and the same angles. And so this applies everywhere inside a rectangle. And so all of these angles right here, all these areas are going to be 2 root 3. So 2 root 3 into 4, that equals 8 root 3. And so the answer choice that matches up is A.